everyone, and welcome back to another new video of pen paper physics. This time I am here with the ray diagrams of a concave and convex mirror. I'll show you how to do this ray diagrams in exams also, and definitely we will discuss the characteristics. But those who are not sure about the concepts of the rules to draw the ray diagrams, please watch the previous video and then come back. It will be easier for you to understand. So those who haven't yet subscribed my channel, please subscribe to my channel and press the bell icon for the further notification. Till then, without any more further delay, let's move into the video. Before we start with the ray diagrams and we come to know that how to do the ray diagrams, we will keep two key points in our mind. Number one, the object is always placed to the left of the mirror. That means the left side of a mirror is always the real side and the right side of a mirror is always a virtual side. More specifically, light ray will always fall on a mirror from the left side. And another key point to remember is at least two rays you have to draw to complete your ray diagrams. As depicted in the picture, this is the left side or the front side of both mirrors, concave and convex. Now first, we will go for the ray diagrams of concave mirror. We will learn how to do the ray diagrams and also the exam tips. But before you start with the ray diagrams, make sure you revise the rules to draw the ray diagrams. That means PF, FP and CC rules. These three rules should be clear to you before you start doing any ray diagram. So here we have the first case for us, that is object is at infinity. Now when the object is at infinity, the light rays that is incident on the mirror are the paraxial rays. That means the rays which are parallel to principal axis. Now for this kind of rays, we will follow the PF rule. That means paraxial rays or the rays parallel to principal axis after reflection will pass through focus. So for both ray 1 and ray 2, we will draw the rays which is passing through the focus. And here you get your image. So what are the characteristics of the images we are getting over here? Number 1, the position of the image is at F. Number 2, the image is real and inverted. Since the light rays are actually meeting at focus, so the image produced over here is the real image. And the size of the image is highly diminished to a point. So here is your exam tip. That means how will you draw it in exam. But before you start with the diagram, make sure that you have taken the proper measurement of P, F and C. Now I will draw two parallel rays. Parallel to whom? Parallel to principal axis. As shown over here. Don't forget to mark the arrows showing the proper path of the light ray. Now since we know that the image is going to form at focus, so we will join the point of incidences with focus and complete our ray diagram. So here is your final diagram. Next, what we are going to study is object is far away. Now, this is not that much of a popular ray diagram in case of a concave mirror. But since we are doing, we will just have a look into this kind of cases also. Here in this case, the object is not at infinity but is at a certain distance. So, in this cases, the light rays that is incident on the mirror are parallel, but parallel to each other, not parallel to principal axis. So after reflection, these rays meet at a focal plane. That means the image is produced at the focal plane. So what are the characteristics that we are getting over here? The position of the image is at the focal plane. It is a real and inverted image, and it is highly diminished, but not a point image. Next case we have object is beyond C. So here AB is the object which is placed beyond C in front of the mirror. Now we will draw two light rays from here. One light ray is parallel to principal axis and the other light ray is a ray passing through focus. Now for the ray 1, we will follow the PF rule, parallel ray passing through focus. And for ray 2, we will follow FP rule. Passing through focus will become parallel after reflection as shown over here. So let's draw the reflected rays. As you can see, now the reflected rays are intersecting at a point. So we will get our image A', B' on that point. So what are the characteristics of this image? The image is produced between C and F. It's real and inverted as the reflected rays are actually meeting at a point. And since the size of the image A', B' is smaller than the size of the object AB, so it's a diminished image. So here we will see now how to draw this in exam. So draw an object AB beyond C. Draw a parallel ray from A. Parallel to whom? Parallel to principal axis. Then join the point of incidence and the focus and extend the first reflected ray. Then draw another incident ray passing through focus. So join A and F and extend it till the mirror. Now from that point of incidence on the mirror, draw a parallel ray. And you will get your intersecting point from where you have to draw your image. Now draw the inverted image of AB, which is A', B'. So here is your final diagram, and positively mark the arrows properly because no arrow, no marks. Next case that we will study right now is object is at C. First we will draw two rays from the tip of the object as shown over here. One ray is parallel to principal axis and another ray is passing through focus. So for ray 1, we will follow the PF rule, parallel ray passing through focus. And for ray 2, we will follow FP rule. That means a ray passing through focus will become parallel. So now let's draw the reflected rays. After drawing the reflected rays, you will get your point of intersection where your image is actually produced. So what are the characteristics of the image that we are getting over here? Number 1, the position of the image is at C. Number 2, the image is real and inverted. And number 3 is the size of the image is same as the size of the object. Now we will follow how to do it in exam. But here the position of the image is precise and the size of the image is also same. So we have to follow a trick to draw the diagram. But first I'll show you how to do the ray diagram in general cases. So first I'll draw the object. Then from the tip of the object, I will draw two rays, one parallel to principal axis and which will pass through focus. Another ray passing through focus, which becomes parallel after reflection. Now you can clearly see that the point of intersection is not at C. So this ray diagram is wrong. It has to be on C. So now we will follow a trick to complete the diagram. The first important point that you have to keep it in mind is you won't mark focus before completing the ray diagram like we usually do for other cases. We will only mark P and C. Now from C, I will draw the object and image of same size. Usually I take 1.5 centimeter or 2 centimeter. Now it's up to you, whichever centimeter you think is convenient for you. So from the same point C, we will draw same size object and image and name them as A and A dash. Now I will draw the parallel incident ray from A and join the point of incidence with A dash as shown over here. Next, I will draw the reflected parallel ray first. And then from that point of incidence, I will join A. And then the point of intersection, I will mark it as F. So first the parallel ray passing through focus and then the ray passing through focus becomes parallel. Now your diagram is complete and the image position is precise. Now since we are doing this diagram in a different way, make sure you give the arrows properly in proper direction. And this one is your final diagram. Next case that we will study is object between C and F. So here the object AB is kept between C and F in front of a concave mirror. Here also I will draw two rays, ray 1 parallel to principal axis and ray 2 passing through focus. Similarly, we will follow PF rule for ray 1 parallel ray passing through focus, and for ray 2 we will follow FP rule. That means a ray passing through focus becomes parallel. So let us complete the diagram. After completing the ray diagram, you will see the rays are actually intersecting at a point beyond C. Draw your image A dash, B dash. So what are the characteristics of the image that we are getting over here? The position of the image in this case is beyond C. The image is real and inverted, and the size of the image is greater than the size of the object, so it is an enlarged image. Now we will learn how to do it in exam. So first, draw the object between C and F. Draw a parallel ray and join the point of incidence and the focus, then extend. Draw another ray passing through F which will become parallel after reflection. And the point of intersection of these two reflected rays gives us the image. Now here I would like to share another tip with all of you. If for some reason your image is not produced beyond C, in that case shift your object towards F and just decrease the size of the object. Then definitely you will get it beyond C. So here is your final diagram. Next we will learn about the ray diagram when the object is kept at F. Here also we will draw two rays from the tip of the object A. First ray parallel to principal axis and second ray a ray passing through the center of curvature. Since the object itself is at F, so we cannot draw a ray passing through F. For ray 1, we will follow PF rule, parallel ray passing through focus. And for second ray, we will follow CC rule, a ray which is passing through center of curvature after reflection follows the same path. So let us complete the ray diagram over here. So we will draw a ray passing through focus, and in case of ray 2, we will just give the reflected arrows. So what are the characteristics that we are getting over here? The reflected rays are parallel to each other, so we assume that they will meet at infinity. So the position of the image is at infinity. Now since we are assuming that they will actually meet at a point, so the image is real and inverted, and since the image is produced at infinity, so we consider it to be a highly enlarged image. Now let's see how we can do it in exam. First we will draw an object at F. Then we will draw a paraxial ray and join the point of incidence and focus, then extend. Then I'll join the tip of the object and the point C and extend it till the middle. But in this ray, we will give both side arrows, as the light is going through the same path and reflecting back also in the same path. So here is your final diagram. But make sure when you complete the diagram, the reflected rays should be parallel to each other. Next, and a very important case that we are going to study right now, the object is between F and P. Here also we will draw two rays, a ray parallel to principal axis and a ray passing through C. For ray 1, we will follow PF rule, parallel to principal axis, pass through focus after reflection, and for ray 2, we will follow CC rule. A ray passing through center of curvature will retrace its path. So let us complete the ray diagram. So for ray 1, the light ray is passing through focus, and for ray 2, it's the same path that light ray is tracing. Now here, it's clearly visible that the light rays in this case are diverging rays, and diverging rays are never going to meet at any point. So the next thing that we will do over here is we will extend the reflected rays in backward direction. That means behind the mirror. But make sure when you extend them backwards, you are not changing the alignment of the light. Where the extended reflected rays meet, there you get the image of your object, A dash, B dash. But here in this case, the characteristics of the image is produced behind the mirror, and it's a virtual and erect image. And obviously you can clearly see over here it's a magnified image. This is the only case where concave mirror produces a virtual image. Now we will learn how to do it in exam. So I have drawn an object between F and P. So I'll draw a parallel ray from A and join the point of incidence and focus, then extend. Then I'll join A and C and extend it till the middle. Now I will extend the reflected rays without changing the slope of the line until they are meeting at a point. Where the extended incident rays meet, there we will get our virtual image. But when you draw the virtual image, make sure you do not use a straight line. You always use a dotted line. And this one is your final diagram. we will study about the ray diagrams of a convex mirror. First case that we will study over here is object is at infinity. So in the same way, the parallel rays will be incident on the mirror. Ray 1 and ray 2 are the paraxial rays parallel to principal axis. So for both of them, we will follow the PF rule where the rays parallel to principal axis after reflection appears to pass through focus. Here, the reflected rays are actually diverging from the convex mirror, but when you extend them backwards, you will see that they are meeting at a point S. It appears that light ray is diverging from point F. So what are the characteristics of the image we are getting over here? Position of the image is at focus. Nature, virtual and erect, since the light rays are not actually meeting at a point. And the size of the image is diminished to a point. Let us learn now how we are going to do it in exam. First, we will draw two parallel rays. Then we will join the point of incidences with focus in a dotted line since it is on the virtual side of the mirror. And without changing the alignment of line, we will extend it in front of the mirror. So here is your final diagram. Next case that we will study over here is object is anywhere. That means in case of a convex mirror, we don't have different position case studies. From point A, we will have two rays, a ray which is parallel to principal axis and a ray which appears to pass through the center of curvature. So for ray 1, we will follow the PF rule, parallel ray appears to pass through focus. And for ray 2, we will follow the CC rule, a ray which appears to be incident at center of curvature will retrace its own path. Now let us complete the reflected rays. After completing the reflected ray, we will see that on the virtual side of the mirror, the extended reflected rays are intersecting. So we will draw our image at that intersecting point, which is a virtual image of AB. That means A dash, B dash. So what are the characteristics of the images that we are getting over here? The image is produced between F and P. It is a virtual and erect image, and the size of the image is smaller than the size of the object. That means diminished. Now let us learn how to do this ray diagrams in exam. First you draw the object in front of the convex mirror. Then draw a parallel ray. And join the focus and the point of incidence with a dotted line and extend in front of the mirror. Then join the tip of the object and the point C. But remember, behind the mirror you will draw the ray with a dotted line as shown with. Don't forget to give both side arrows on this ray. You will draw your image but with a dotted line since it's a virtual image. So here is your final diagram.
Hey there, welcome back again after the video. Hopefully your concepts are clear right now and you will rock in your exam. And the teachers, those who are watching it, thank you very much for watching. Thanks to all of you for watching and learning. Keep learning physics. But before you go, if you have any suggestion or anything, please suggest me in the comment box, and my official Facebook page and Instagram page link is given in the description box below. Go do and check and follow me. Till then, thank you very much. See you in the next video. Bye-bye.